The minimum bending radius for 12 AWG solid wire is 1 and 1/4 inches. This requirement is crucial for maintaining the integrity of the wire and ensuring safe electrical installation. Bending a wire too sharply can cause several problems. Firstly, it can weaken the conductor, potentially leading to breaks or fractures within the wire. These breaks can reduce the wire's current carrying capacity and create hot spots, increasing the risk of fire. Secondly, sharp bends can damage the insulation surrounding the wire. Damaged insulation exposes the conductor, creating a shock hazard and increasing the likelihood of short circuits. Thirdly, improper bending can make it difficult to terminate the wire properly at outlets, switches, or circuit breakers. This can lead to loose connections, which are a common cause of electrical problems. When working with 12 AWG solid wire, it's important to use tools and techniques that help you achieve the correct bending radius. Wire benders and conduit benders can be helpful for making smooth, consistent bends. When bending by hand, use the sweeping motion and avoid kinking or creasing the wire. Always consult the National Electrical Code, or NEC, and local electrical codes for specific requirements and guidelines related to wire bending. The NEC provides detailed information on conductor installation, including minimum bending radii for various wire sizes and types. Following these guidelines ensures that your electrical work is safe, reliable, and compliant with regulations. Understanding and adhering to the minimum bending radius for 12 AWG solid wire is a fundamental aspect of safe electrical practices. By taking the time to bend wires properly, you can prevent potential problems and ensure the long-term reliability of your electrical system. Remember to always de-energize circuits before working on them and to consult with a qualified electrician if you have any questions or concerns. Electrical work can be dangerous, so it's important to take all necessary precautions. When installing electrical wiring in residential applications, such as branch circuits for lighting, receptacles, and small appliances, 12 AWG solid wire is a common choice. It's crucial to understand the specific bending requirements for this type of wire to ensure safety and code compliance. Always refer to the latest edition of the NEC and any applicable local codes for the most up-to-date information. In addition to the minimum bending radius, other factors to consider when working with 12 AWG solid wire include the proper support and securing of the wire, the correct size of conduit or cable clamps, and the appropriate torque for terminations. These factors all contribute to a safe and reliable electrical installation. The NEC provides tables and guidelines for determining the appropriate support intervals for different types of wiring. It also specifies the types of cable clamps and connectors that are suitable for use with 12 AWG solid wire. Properly torquing terminations is essential for ensuring a secure electrical connection. Loose connections can cause overheating, arcing, and even fire. Use a torque wrench to tighten terminations to the manufacturer's specified torque value. Regular inspections of your electrical system can help identify potential problems before they become serious. Look for signs of damaged wiring, loose connections, or overheating. If you notice any of these issues, contact a qualified electrician to investigate and make repairs. Maintaining a safe electrical system is an ongoing process. By understanding the requirements for wire bending, support, and termination, and by performing regular inspections, you can help protect your home and family from electrical hazards. Electrical safety is everyone's responsibility. Always take the time to learn about the potential hazards of electricity and how to prevent accidents. If you're not comfortable working with electricity, hire a qualified electrician to do the work for you. When running 12 AWG solid wire through a conduit, ensure that the conduit is properly sized to accommodate the wire and any other conductors that may be installed in the future. The NEC provides tables for determining the maximum number of conductors that can be installed in a given size of conduit. Overfilling conduit can make it difficult to pull wires and can also damage the insulation. When pulling wires through conduit, use a wire lubricant to reduce friction and make the job easier. Avoid using excessive force, which can damage the wires. After pulling the wires, inspect them carefully for any signs of damage. Replace any damaged wires before energizing the circuit. Proper grounding is essential for electrical safety. Ensure that all electrical equipment is properly grounded to prevent electric shock. The NEC specifies the requirements for grounding electrical systems and equipment. Use only approved grounding connectors and follow the manufacturer's instructions. Regular testing of your grounding system can help ensure that it is functioning properly. Use a ground tester to verify that the grounding impedance is within acceptable limits. If you have any questions or concerns about grounding, contact a qualified electrician. Ground fault circuit interrupters, or GFCIs, are designed to protect people from electric shock. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if a ground fault is detected. GFCIs are required in certain locations, such as bathrooms, kitchens, and outdoor areas. Test GFCIs regularly to ensure that they are functioning properly. If a GFCI trips frequently, it may indicate a problem with the circuit. Contact a qualified electrician to investigate the problem. Arc fault circuit interrupters, or SIs, are designed to protect against fires caused by arcing faults. SIs monitor the current flowing in a circuit and quickly interrupt the power if an arcing fault is detected. SIs are required in certain locations, such as bedrooms and living rooms. Test SIs regularly to ensure that they are functioning properly. If an FSI trips frequently, it may indicate a problem with the circuit. Contact a qualified electrician to investigate the problem. Surge protectors are designed to protect electronic equipment from voltage spikes. Voltage spikes can damage or destroy sensitive electronic components. Surge protectors should be installed on all circuits that power electronic equipment. Replace surge protectors periodically, as they can degrade over time. Uninterruptible power supplies, or UPSs, provide backup power in the event of a power outage. UPS can keep critical equipment running during a power outage, preventing data loss and downtime. UPS should be used for computers, servers, and other critical electronic equipment. Replace UPS batteries periodically to ensure that they are functioning properly. When working with electrical panels, be aware of the potential hazards. Electrical panels contain high-voltage components that can cause serious injury or death. Never open an electrical panel unless you are qualified to do so. Always de-energize the panel before working on it. Use insulated tools when working near energized components. Wear appropriate personal protective equipment, such as safety glasses and gloves. If you have any questions or concerns about electrical panels, contact a qualified electrician. Remember, electrical safety is everyone's responsibility. By taking the time to learn about the potential hazards of electricity and how to prevent accidents, you can help protect yourself and others from harm. Always follow the NEC and local electrical codes. If you're not comfortable working with electricity, hire a qualified electrician to do the work for you. The information provided here is for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Firstly, ensure the power is off. Secondly, verify the power is off. Thirdly, wear appropriate safety gear. Fourthly, double-check your work. Fifthly, test the circuit after completion. Sixthly, consult a professional if needed. Seventhly, always follow local codes. Eighthly, never work alone. Ninthly, stay focused and avoid distractions. Tenthly, take your time and do it right. This guidance emphasizes the importance of safety, accuracy, and adherence to standards when working with electrical systems. Always prioritize safety and seek professional assistance when needed to ensure a reliable and safe electrical installation. The minimum bending radius for 12 AWG solid wire helps to ensure the safety and longevity of electrical installations.